Let's start. Bismillahirrahmanirrahim. So, this is about the lesions of the descending tracts. We did the anatomy yesterday. Welcome back. So, this particular circuit diagram from Genon will be sort of a roadmap in today's lecture. So, you need to be comfortable with this. We will come back to it. Let me just show you around what's going on. So, this circuit diagram will be shown quite a lot. Then you will see pictures like these, uh, terms like these, decortication and decerebration. Mind you, these are the two main terms that we'll be discussing today. These are the two main terms, especially decerebration, that comes in your exam. Okay? This, by the way, is a decerebrate posturing, and this is a decortication response or posturing. Okay? Uh, Abdullah, I won't. Obviously, this is a good thing if you want to consult additional books. But I tend to integrate. I tend to draw from various books so that the kids don't have to. So if you go through the lectures diligently, and yes, if there is something that needs clarification, then refer to other books. That's fine. But certainly, if you develop a habit of studying from different textbooks, standard textbooks, that's a wonderful habit. So yes, you may add Ganong to your uh, scheme of things, maybe another book or two, but try to at least cover Guyton once or twice, and then add other resources. I say this because basically your exam will come from Guyton, and it's really silly if you know advanced stuff and peripheral if you don't master the stuff that's given in Guyton, and you don't do well in the exam. I just don't see the point. My advice to students is you should be exam ready, and then on top of it, the sky is the limit really. You can study all you want. Okay? तो बिल्कुल Guyton and then plus other books, that's fine. ठीक है? So for example, this diagram is not in Guyton. This is from, I can't even remember which book this is from, but I do consult very many books to prepare these lectures. Okay, so beyond this, we will be looking at upper motor neuron lesions. We will be going into details of decortication, where you will see a slide like this. We'll go through bits of this individually. Okay? Then upper motor. Welcome back. We'll re-emphasize the different in posture. Obviously, we'll explain what this is, the upper limbs. The rest is the same. Then again, this diagram will be referred to explain to you the role the cerebellum plays in all of this. This is the cerebellum here. Okay? And we will come to the final point where I will sum up. Hopefully, let's see how the lecture goes. I'll be summing up this very nice diagram, and here is the legend at the bottom. You will understand, inshallah, as we go along what this is. And these are the final points, final slides. One of the final slides, that as you go from rostral to caudal, the level of the brain injury from forebrain to medulla, you get various types of rigidities, and you will understand hopefully when we come to this slide after the whole lecture, inshallah. And at the end, just a small slide to explain, to really enumerate what happens in the lower motor neuron lesion. The causes are clear, and a few points here really will need explanation. I suspect, I fear that by this time you will be exhausted mentally. So I'll try to be quick on this. However, this is an important question. The difference between, say, the state of the muscle in upper motor and lower motor neuron lesions. Okay, in upper motor there is spastic paralysis, while in lower motor neurons there is flaccid paralysis. So this is an important point. So please bear with me, okay? I hope you had good sehri today. In my defense, I have warned you about today's lecture, okay? I'll try to make it as painless as possible, okay? I promise. So, let's take from the first point onwards, okay? If you understand this diagram, most of the issues will be resolved. So I think we should take some time. What I had in mind was if we can cover this diagram and maybe decortication. So this till this slide, if we cover, take a break, and then come back and do decerebration onwards. How does that sound? So I will require your attention on this diagram. Okay. Now I'll bring it closer. Okay. Can you see the top part of this diagram clearly now? Can you? Wonderful. Now, if you look at this whole patch here, this whole patch, this is the cortex, this bit here, cerebral cortex. Okay. This dotted line is the cerebral cortex. Forget about the D and the A. Just look at the dotted line. Okay, this is representing the cerebral cortex and the cells of the cerebral cortex. Okay. Then you have another dotted line here. This is a level of the brain under the cerebral cortex. So this is a subcerebral cortex sort of level. Okay. This is the topmost part of the brain. Then you have the part which is under this cerebral cortex. Then you have the brainstem here. Okay? You have the cerebellum on the side. Okay? And then as you go along further down, I'll just zoom out for a bit. Here you have the muscles, the recipient of the whole program. Do you see the orientation now? Cerebral cortex, a level below cerebral cortex, brainstem, cerebellum, muscles. Yes, need some feedback quick, please. So I'll be stopping a lot to take questions, okay, because this is a crucial point. Okay. Somebody asked me about spinal cord. I'm just waiting if there are other questions. So, spinal cord is represented by these fibers. And if you can see that these are the motor neurons. Okay, I'll go in detail, but these are the different type of motor neurons. They reside in the spinal cord. Since this is a schematic diagram, he hasn't really gone. Welcome back. I don't know what I missed. I'm not looking at the screen. I was just responding to the spinal cord question. These tracts represent the spinal cord. If you notice, these are motor neurons. Okay. And if you look closer, he has shown one type of extensor muscle and one type of flexor muscle. Okay, this is a flexor muscle, extensor muscle. Okay. So this is the general scheme of things, right? Now, I'll zoom in again. Okay. Right. Now, look at the way the fibers have been made. Okay. So there are these two fibers symbolic fibers, which start from the cerebral cortex and end in the on top of the tracts that we read yesterday. Which were those tracts? The tracts were reticulospinal, okay, fibers, pons, reticulospinal fibers, medulla, okay. Then we had corticospinal fibers. Then we had rubrospinal fibers. And final point was vestibulospinal fibers. Now you see you can also, this is a good diagram because you also see the anatomical connections without the jargon of anatomy. So it's just bare bone picture showing who is where is the exact address when we're talking about the function. Okay? So if you've understood these fibers, let me just recap. So there are short fibers, these two. This is cerebral cortex communicating with the reticulospinal fibers. Okay, so it is stimulating. The plus sign is stimulating. So cerebral cortex is stimulating the reticulospinal fibers here and here. Did you get that? And this is what actually happens. ठीक? Okay, some more please. Some more yeses, okay, no, I don't know. Welcome back. Okay, great. Then you see that you have the cerebral cortex sending its longest fiber, the corticospinal tract, right down to the level of the spinal cord ventral horn motor neuron. Right here. Okay. So if I were to zoom this in, so look at this corticospinal tract. It came from the cerebral cortex directly, no other business in the middle, came directly on top of this neuron. I can tell you from here, you can't see it, but it's a flexor alpha motor neuron. Okay, going to the flexor muscle. Okay, so the corticospinal tracts go directly or on either the interneurons of the spinal cord or directly on the alpha motor neuron of the ventral horn, which are innervating skeletal muscles directly. This was covered yesterday, right? We go back up again. We have explained the corticospinal tract. What is left is this guy now. Well, guess what this is? He has assumed, to make it simple, because this would have been a very messy diagram. It is already messy. It would be super messy if he had shown the interneurons. So this is a symbolic representation of where the thing ends. Okay, the rest is up to us to fill in the gap. As I mentioned, that there are interneurons and direct motor neurons themselves. To keep it simple, he has just made the neuron. Okay, now. What is this? What is this? Red nucleus. Well done. Okay. Now if I touch the screen, he focuses on my finger. I need to be careful. Let me use the cursor. Ask me a question about whatever. If my sound decreases or whatever, just let me know. This is the red nucleus. Okay, this is my cursor. And the cerebral cortex fiber communicates with the red nucleus through short fibers. As you can see, there are short fibers here traversing all the way to the brainstem. There is the long fiber where where the cerebral cortex putting its influence directly on the ventral neuron. And this, you should know now that there are some fine movements which the cerebral cortex would like to activate or control itself. Something which I said yesterday. Today you are looking at it a bit more diagrammatically. And then there are short fibers running from the cortex called the corticorubral fibers, which end up directly on the red nucleus. They stimulate it, okay? And from this nucleus, you have the rubrospinal tract going down and again to the flexor alpha motor neuron, right? Is this clear? I've explained to you whatever is happening. Mainly, there's a cerebro-rubral fiber here as well, which is cerebello rather, which is coming from the cerebellum and stimulating it as well. But this is really a minor point, or maybe you can make a note of it just to complete the whole sequence. So I've described to you how the cerebral cortex is depicted in this picture. Any questions on the cerebral cortex and the fibers that it sends down in this diagram? I'll take a pause here and take questions. If there no questions, what about the rest? So which of these fibers would be involved in controlling of movements, anti-gravity? Beta, I'm coming to that, Moz. Moz, have you been taking the rest of my lectures? I didn't really see you. Okay. Okay. Osama, better, as you can see, the corticospinal is the longest here. Okay. If you're talking about the longest direct cerebral cortex fiber, then it's corticospinal tract, right? Okay. Let's move on. So now I'll focus here on this bit here. This bit here. Okay. I hope it's, oops. Okay, now, as you can see that cortico-reticular fibers these are cortico-reticular fibers, these two that he has depicted. Remember, this is a schematic diagram, guys. This is not just two fibers. There are thousands and thousands of fibers like this coming down. And these are not just one nuclei, they have many nuclei, okay? So anatomy will be grinding you on these details very soon, hopefully. And they'll be thanking us because we have done the spade work for them. They just need to come and really just revise these bits with you. Anyhow, so these cortico-reticular fibers, they come down on top of these reticular nuclei. One is, this is now additional information. So you have the excitatory reticular formation and the inhibitory reticular formation. I think I've drowned the... So check this out. This is important for you to understand. The cortex stimulates the excitatory fiber, which is excitatory to the extensor gamma motor neuron. This was the flexor alpha motor neuron. Now the green thing is the extensor gamma motor neuron. Please mind the difference between two of these neurons. They are different. Alpha motor, gamma motor. Okay, you know this. Now, when the cortex stimulates the pons reticular formation centers, they are basically excitatory in nature because they excite the extensor neurons. So this stimulation leads to excitation of the extensor neuron. However, this here is inhibitory. These are inhibitory neurons by their nature, as you can see right here. They are inhibiting the same neurons, ventral extensor neurons, gamma efferent neurons, okay? To keep a check and balance on the stimulation. You will see a lot of this in CNS. something is being stimulated, at the same time it's also being inhibited. This is, these local circuits are there to keep a balance, so that whatever the target neuron is, it doesn't go beyond its scope. Okay, so you have a very tight kind of regulation right at the level of neurons in CNS. It's beautiful. It's intricate, but it's beautiful. Okay, it's controlling the controller, if you know what I mean. Anyhow, so cerebral cortex stimulate by stimulating an inhibitory nucleus, an inhibitory fiber, actually increases inhibition. So although this is a plus, but eventually this plus will stimulate a inhibitory fiber, enhancing this minus. Do you understand? This will help you understand cerebellum one day as well. The plus and minus can be confusing, so I'm taking my time here. Repeat. Okay, who else is for repeat? This is not a call for repeat. I just want to know. So very quickly recap. Welcome back. Here we see the communication of the cerebral cortex with the reticular formation, right? So in the reticular formation, it sends down excitatory fibers for both. However, you have excitatory reticular formation fibers, which are excitatory to the gamma efferent, and you have inhibitory reticular formation fibers, which are inhibitory to the gamma efferent fibers of the spinal cord. Cerebral cortex, though, stimulates both. Okay, so it's obvious that when you stimulate an excitatory fiber, which is by nature anatomically an excitatory fiber, the synapse that it does with the gamma efferent is excitatory, the net result will be increase in excitation. Okay, and when you stimulate a inhibitory kind of fiber, the net result will be inhibition. This is just to tell you the skeleton of this, the whole circuit diagram of this. We will manipulate this later on. Okay? Okay. A very important point is this guy here. Please make a note of this straight away. What is this? This is the ascending sensory fibers via ALS. I have this sinking feeling that you don't know what ALS is. You haven't done ascending fibers, have you? Sensory physiology? Chalo. But you do know that sensory information goes up the ladder, right? You know this. Yes, you know that the sensory fibers, sensory information goes from yes, the sensory fibers, the sensory information ascends, right? We are on the descent now, but Dr. Noora would have taught you that sensory information goes from effector organ upwards. There are two ways, there are two main tracts of this sensory information. One is the ALS. Here. The other is D. Welcome back. The abbreviation basically is a good mnemonic for its anatomical position within the spinal cord and the CNS. So anterolateral means it is placed anterolaterally in the spinal cord. So no rocket science here. Okay. However, that's not our focus at the moment. Our focus at the moment is a very, very important point that I want you to know. Is that this ascending fiber, while it was minding its own business going through the brainstem to the upper areas and eventually telling the cortex of the wonderful experiences that the muscle is having, okay, and the surrounding fascia, it gave a excitatory branch here, right here. It's a point here, right? So this excitatory fiber is given to the excitatory pons center of the reticular formation. Sort of gives it a wake up call. Right? I'll give you an example. You will understand what is going on. What is going on here? Now, here. Okay. Now, this is, guys, this is a sensory information stimulating descending motor. Yes or no? Yes? Come on, guys, the rest of you. Did you get my sentence? This is sensory information which basically had little to do with descending motor output of the motor cortex. But here you have an evidence that it does have something to play. Okay? Here you have a crossover of the two worlds, sensory going up, motor going down. Okay? And you have proof that it becomes a bit naughty here and tickles the excitatory reticular formation nucleus, which is, by the way, excitatory to the gamma. It and is being excitated by the cerebral cortex in the first place. This also excites it. Okay? If this you have understood, let me quickly ask you a question. I mentioned the crossing over of the two worlds, sensory and motor. I taught you a point yesterday about this crossover at a separate place. Do you remember that separate place? That the other place where this crossover takes place judiciously, formally, where sensory and motor become one, eh? Or partially one. Come on. Yesterday's lecture. Welcome back. As I was saying, it's right. The question answer is also right there, ironically, for the trained eye. Nahin? The answer is going for 1, 2, 3. Okay, nobody spoke. Nope. No Tukke Abdullah. This guy. Corticospinal tract. Still no? Remember we talked about its composition, Einstein's? And I mentioned to you that a good solid fraction of the fibers, sensory fibers, constitute the corticospinal fibers, the tract. We just did it yesterday at the... Yes. Yes, Imad. Thank you. Right? Anyhow, so there are crossovers between the sensory and the motor. That was the point. Okay? Coming back to this point, please remember this point. This will come in very soon. It will come after the break with a bang. This point, remember this point. Right, we move forwards. What else is there to study? Zooming out. Now we are looking at the muscles themselves. Okay, let me adjust the diagram and we'll see. Nope, it's not allowing any more magnification. We'll have to do with this. Can you see the muscles? Can you see this area here? I'll walk you through it. If you can just see the tracts going in and out and the color scheme. This is green. this is blue, this is red. Yeah, you see the main things. Forget about if you can't read the stuff. It's you already know it. Okay. Okay, I'll just walk. Welcome back. I'll just walk you through these points. This he has shown, as I mentioned, a gamma motor neuron. Okay, the gamma motor neuron comes here and goes into your extensor muscle and innervates the tapering end of the muscle spindle. Nothing new, I hope. If this is new, you seriously are in the wrong class. Okay? So gamma efferent coming here, going into the muscle, minding its business, going to the muscle spindle, tapering end, and that's that. And you know what gamma efferents do. Okay? From there, you see the red stuff. This is the sensory fiber emanating from the muscle spindle, going to the dorsal horn and coming into the synapsing with the alpha motor neuron. Right? Then you have, so we are just completing the circuit diagram for the stretch reflex now. Sensory afferent originating from muscle spindle, going through the dorsal root into the spinal cord, synapsing the only monosynaptic reflex that you've read up till now, probably the only one that exists, directly onto a motor neuron, which by the way is an extensor alpha motor neuron. Okay, you already know this, we read this in knee jerk. Okay, quadriceps femoris is an extensor of the knee, so nothing new there either. Okay, so this synapses here, and this alpha motor goes to the extrafusal element of the same muscle. Nothing new. So mind you, I am now moving my cursor in a circular fashion. This, bache, is the reflex arc of the stretch reflex. Is it not? Say it with me. Yes? Reflex, stretch reflex. Okay? Cool. What is left is Mr. Lonely flexor alpha motor neuron. It's right here, right here. Okay. It is going to the lonely flexor muscle on the side. Nothing fancy going on here. Welcome back. Another very interesting thing that you immediately should learn is this information. Abdullah, I knew somebody silly would ask me this question, and you are the silly guy. But of course it does. We've read this already. Muscle spindles are present in every muscle. But depending on the type of muscle, the number of muscle spindles vary. He has not shown muscle spindles here because there is no point here to explain muscle spindle here. Okay? As we'll go along and we'll see how messing up this circuit can cause changes in the overall. You will know that this is the more important focus of this diagram and not the flexor response. Okay, just hang on with the program, you'll understand. What I was saying was, an immediate cache of knowledge is waiting for you right here. Check this out. What do you see in this red box? You see that the gammas, the gamma family, is under the reticulospinal tract influence. Okay. You see the flexors, the flexor alpha is under the influence of the corticospinal and the rubrospinal. As we mentioned yesterday, yesterday's lecture will keep coming back. Extensors are under the brainstem tracts. I mentioned this yesterday. Hopefully you remember. Flexors are under cortico and rubrospinal tracts. Remember? And finally, extensor alpha again is under the influence of vestibulospinal, which is a brainstem level of descending tract. Okay? This was scattered information yesterday, but today you see it in a line. So I hope that this consolidates your understanding. Yes? The rest. Hurry up. The rest. Okay. Now we move to the final point, the final frontier. Not by importance though, but it's a peculiar point. The cerebellum. We'll look at the cerebellum now. So I don't want you to. This is the cerebellum. Okay. It starts from. Let me go free here. Um, this. This. This is the cerebellum. Okay. Whatever is in here is cerebellum. Oh, by the way, I missed out the vestibular nuclei. It's part of this, not anatomically, but physiologically speaking, it's part of the cerebellum. Again, I mentioned this yesterday. Okay? I'm going to clear it out so that I explain this to you. Fine? Okay, so this is the cerebellum. I want you to focus on the vestibular nucleus. Here, what's going on here? This is the vestibular nuclei, which is the originating point for vestibular. Welcome back. As we were saying, we were looking at the vestibulospinal fibers coming from the vestibular nuclei, and terminating on the extensor alpha motor neuron. Okay? Now, you can see, let me just exaggerate it for you. You can see that the cerebellum is inhibiting the vestibular nucleus. Okay? And there are all sorts of negatives here. Okay? So it's suffice to say at this point where we have not formally read the cerebellum, that cerebellum basically inhibits the daylights out of vestibular nuclei. Okay? That's that. Okay? So, hello. Earth calling Mars, Earth calling Mars. Are you guys with me? All 69 of you. I know it's a bit too much in the morning. You're fasting, mashallah. May Allah accept it from you. And that's why I said there will be a break in between. Okay? Now, could you imagine me following this up with the whole lecture? I mean, you'll be up in arms. You'll be chanting slogans. Okay? Chalo. Let me just finish this off, give you a break, and then reconvene. Now, if vestibulospinal fiber is to stimulate this extensor flexor, which it does, cerebellum won't have it. Cerebellum is continuously inhibiting this neuron. Okay? So, it is being kept in check by the cerebellum. Alright? Let me say it in one other way, shall I? If I were to cut the cerebellar influence, inhibitory influence, if I were to get rid of this cerebellum here, what do you think will happen at this point, the extensor alpha? Welcome back. Maas gande bache. Just stay with the program. No. Just tell me what happens in the circuit diagram. Don't jump ahead. Tell me what will happen to the extensor alpha motor neuron. It would be released from the inhibitions of the cerebellum, would it not? Yes, Noor, Shabash. Yes, Abdullah. Yes, intense firing. Because it's free from the inhibitions of the cerebellum. Okay? This is free now. So it will go into overdrive. Yes. Well, guess where it's going? Let's zoom out a bit. It's going. Where did it go? Yeah, here it is. It's going into the, it's basically supplying the extrafusal fibers of the extensor muscle. ठीक है? So what will happen in the extensor muscle? They will become overexcited, extended, tense. Can we say spastic? Spasm? Yeah? So, if you disturb the cerebellum, spasticity ensues. What is spasticity? Let me say it now so that it stays with you. Spasticity is when you overstimulate a muscle, and this overstimulation causes a functional disability of the muscle such that it cannot do its job. We call it spastic paralysis. I hope this stays with you throughout second year, inshallah, and your clinical years in neurology, in medicine. The spastic paralysis that we have done today. This is why we say that physiology is the basis of medicine. So this in, okay, I'll repeat it. I just said that if you remove the cerebellum, okay, this vestibulospinal tract mediated overstimulation of extensor alpha motor neuron will lead to overstimulation of extensor muscle. It will go into spasm and become, welcome back. Was, ठीक है? Jaldi, I have to make a point. So, spastic paralysis, we've done. Can you see what I write? Versus flaccid paralysis. Did you get that? ये क्या चक्कर है? What is going on here? So we just discussed spastic paralysis, but there is a flaccid paralysis as well. Yes? This is where I wanted to come. I didn't want to come actually. We just flowed to this point. Spastic paralysis we've done. Flaccid is when you cut the nerve. So all of this is upper motor neuron lesions. When you do a lower motor neuron lesion, you cut the nerve. You cut this nerve here. You cut it. When you cut this nerve, this muscle will again go into paralysis. But what kind of paralysis? The overexcitatory type. You've denervated it. It will go into flaccidity. So that paralysis is also a paralysis, but that is of the flaccid type. सही है? This is a big question, Viva question and MCQ question. What type of paralysis happens in upper and in lower motor neuron lesions and why? You know this now. No excitation, nothing. It becomes flaccid, ढीला. ठीक है? चलो. Can we do one cool thing and then I'll let you go? I'm being mean here in the sense that if I slip in one more thing, my job will become easy. Sir, but we didn't actually cut anything in upper. Now, beta, now we did not, Abdullah. We did cut in lower motor, which I just showed you with my hands. In lower motor neuron lesion, you cut the nerve, which is coming out of the spinal cord. You have read this as the word denervation. Welcome back. Lesion is because it's doing something bad. Lesion is not only, okay, this is your concept. Lesion doesn't need to be anything being cut or pressed or destroyed. Lesion means there is something going on which is not cool, right? Which is not normal. That's lesion. ठीक है? चलो. Now, let me cheat here a bit, explain one more bit so that our job becomes easy later on. ठीक है? Final point before we go on our very well deserved break. ठीक है? It's a trick. So stay with me. Focus on this. Focus here. This is the gamma efferent neuron. Let me say if I were to overstimulate it this here, forget about the inhibitory arm. I've just knocked it out. I'm overstimulating it somehow from this circuit, and this really has become very angry. Tell me what will happen to the muscle because of this harkat and why. This you should be able to work out. I have invested a lot in the gamma efferent functionality. Come on, make us proud. Noor says spastic paralysis. Spasm. Hi, repeat. Bache, repeat. Breaks the sequence. Moaz. Abdullah, you're a cool guy. Repeating it for Moaz. Moaz, I said, if you overstimulate the extensor gamma, what will happen to the muscle? That's what I said. Giving some more seconds to the other people to join in. What will happen to the muscle, bete, in this situation? You have not touched the alphas, you are only overexcited the gamma. Any more answers? Any new answers, sorry, from other people, new people? Nahin? Noor and Abdullah were spot on. The muscle will go into spastic paralysis. Do I need to explain that, guys? How it will go into spastic paralysis? By the exaggerated stretch reflex. By the exaggerated stretch reflex that this overdriven gamma efferent will trigger. Welcome back. It will keep stretching the spindle. The sensory fibers will keep sending stretch values input into the spinal cord, and the motor neuron will keep contracting the extrafusal fiber. This is like a perpetual positive feedback loop here, which will keep on overexciting the extensor muscle, and it will go into spastic paralysis. We, by the way, also call it the gamma loop. I'm cheating now, right in front of you. This is called the gamma loop. Wait, spelling. This is all Genom, guys, by the way. Okay? Did you get that? Did you get what gamma loop is? Gamma efferent ka loop. Loop. Okay? Now I'll leave you with a question. I promise I'll leave you now. I'll leave you for a good 30-minute chill out break. Stretch your legs, go for a walk, speak to Ammi about iftari, blah blah blah. Okay? Where is the gamma loop? Osama, bete, look at my cursor now. Look at this. Ye dekho. It's going in. Okay? The green stuff goes in, messes up the spindle, red stuff goes berserk, disturbs the blue stuff comes and sort of disturbs the muscle. Loop ban gaya na? This is the loop, circular loop. Yes, Osama? Yes, come on, hurry up. Great. Now, the question I'm leaving you with is this. We have just established that disturbing the vestibulospinal fibers by removing the cerebellum will cause spasticity in the muscle. Also, if you do the gamma loop through exciting the gamma efferents, again the muscle will go into spastic paralysis. We've just done this, right? Go into spastic paralysis from both this and this way, right? Now, question. Question is, if I were to section, what color should I use? What color? There needs to be a unique color, guys. Yellow color. Chalo. If I were to section spinal cord, cutting it, dorsal horn, what will happen? Which spasticity will be relieved? This one or this one? More on this when we return. Okay? Take a break, guys. Thank you for being an awesome class. The awesome 68 or something students that I have, but you guys are awesome. Okay? Abdullah, chup. No, क्या वो कहते हो वो जो when there's a program going on and you have seen the advanced episodes and you tell the guys who haven't seen it, there's a word you call it. Spoilers. Sorry, I'm getting old. Spoilers, no spoilers. ठीक है? चलो, see you back. Okay, Allah Hafiz for now.